Welcome to Unit 8 of 4th grade math. This unit is all about geometry, and it is jam-packed with information that you are going to need in this unit. Make sure you have this note sheet handy as we're going to talk through some of these information. We're also going to have lots of additional notes, so make sure that notebook is ready. Here we go. Our first concept is talking about all the different aspects of lines, line parts, things of that sort that might help us. So the very first thing we see right here is just a dot. We call that simply a point. Points are important because they connect our lines, line segments, shapes all together. Most of the time, a point is identified with some type of letter. Our next one is a ray. A ray has a starting point, and it goes on forever in a direction past another point. Typically, these points, again, are labeled. Maybe they're labeled A, B here. And then we can actually give this ray its name. And its name would be A, B. And then we put a ray symbol on top of it, making sure the arrow points in the direction that our ray would go. And that's how we would name this. Our next one is called a line segment, because a line segment has a start point and it has an end point to it. We're going to just abbreviate line segment because it is written over here also for you. Line segments, again, can have letters to them with the start point and the end point. And how we would name it would be C, D, and then a straight line above it, showing that it's not going in both directions forever. Our next one is simply just a line. Now I always find it funny that teachers say, "Class, line up." Typically, a teacher does not actually want a line, which goes on in both directions forever. Most of the time, a teacher probably would want a line segment, a starting and an end point, but saying, "Hey, class, line segment up," would kind of sound funny. So we do say line, but keep in mind the difference between these two. A line would have some points in it. We'll give these E and F. And then to make the name of it, it would say line EF. And then we would put that line above it with the arrows on both sides to show that it's a line going in both directions. All right, our next thing we're going to talk about is an angle. An angle, if you notice, is just made up of two rays, and they meet at a vertex. So we have ray BA, and we have ray BC. And they meet at the vertex point of B. B would be considered the middle. Now we can name an angle also. To give an angle a name, we would write a little angle symbol. And it doesn't matter what kind of angle it is, if it's obtuse, acute, right? We would always use this symbol for it. And then we start with one of the outside letters. The vertex is always in the middle. And then we end with our last letter. So this is angle ABC. And we can see where that angle is if we had followed along. The next one here is called parallel. What I like about the word parallel itself is it actually has parallel lines right there in the middle of the word. So this is parallel lines. Parallel lines are like railroad tracks. They are never going to cross. When those lines continue in both directions forever and ever, they will never cross at any point. That's what would make them parallel. The next one is perpendicular. Perpendicular lines are definitely a little bit on the tricky end, only in the sense that they have to be two lines that cross at 90 degrees. So you can see this box right here on this shape shows that 90-degree crossing. Whether your shape is turned, right here we have that 90-degree crossing. The only way they can be perpendicular is if they cross at 90 degrees. If we have two lines or line segments that cross maybe something like this, they are not crossed at 90 degrees. We would call these ones intersecting lines. Just like an intersection on a road. We have crossing lines. Sometimes they're at 90 degrees, but they might not be. So these could be intersecting lines. All right, moving on. Types of angles is an important thing in this unit. The very first one is acute, and I like to always say, it's such a cute little angle, because typically when we think of cute things, we think of small little things. An acute angle is a measurement of an angle that is less than 90 degrees. The next one is a right degree. Right degrees are usually denoted with this box. And a right angle has to have exactly 90 degrees. The next one on our list is obtuse. And I always like to say this one, kind of like a tuba with a big booming voice. I always say obtuse because it is very big. This is an angle that measures more than 90 degrees. Our next one is probably a newer concept for you, which is a straight angle. Straight angles measure exactly 180 degrees. And the next one probably is a newer term, a reflex angle. A reflex angle measures bigger than 180 degrees, but less than 360 degrees. And if we had an angle that was measuring all 360 degrees, we would say that made a full rotation. Circles have 360 degrees. So that one would be a full measurement. We're going to be practicing measuring angles this unit. This device down below is called a protractor. A lot of this unit, the protractor, might already be on the angle for you, kind of like this example at the top here. Sometimes it's not, and you're going to have to use a protractor and move it onto the shape. So we need to understand and know how to use a protractor. But before we do that, let's think of some qualities about this angle. Hopefully you notice that it is bigger than 90 degrees. So we know that this is an obtuse angle. And what do we know about obtuse angles? We know that they have to be bigger than 90 degrees. So we know that our measurement should say something bigger than 90 degrees. So how do you use a protractor? On the bottom, in the middle, there is this little dash. Sometimes it's a circle, but usually it's some kind of dash or circle. That is where we line up our vertex. And in this case, O is our vertex. So we're going to put the protractor right onto that vertex. The other part that we're going to see is one of our lines should be pointing at a 0. If we look at the protractor, we see there are top scale numbers and bottom scale numbers. The bottom line in your angle tells you which scale to use. So right now, this A ray is pointing to the 0 of the top scale. We then are going to travel all the way from the A up our scale, all the way around to where it stops. And where it stops right here is between 140 and 130. If we count all these small little tick marks, we would see that that was 5. So our measurement is 135 degrees. Now, if you were thinking that it is the other scale of numbers, you would have seen that it would have been 45. And as we look at this angle, we would see that 45 would just not make sense. And so if you're unsure which number it is, try to look at that classification of what kind of angle you have. So this one is 135 degrees. Using a protractor is going to take some practice. Sometimes you need to turn your paper so that one of the lines is on the bottom and then the other line is going up somewhere into the air, just like the shape of our protractor here. The reason we have two scales of numbers is because sometimes our angle points the other direction. Sometimes our angle might point something like this. And then in this case, we would have wanted to use the other scale because this would have been 0, which would have been the bottom scale number on our protractor. So that is why we have two scales of numbers. The next concept is called adjacent angles. Adjacent angles are two angles that have the same vertex. So right here, they have the same vertex of y. I'll move my arrow a little bit so you can see the y. All right. So we can look at some pieces of information that we know. We know that the entire angle of both of them together is 80. We know that one side is 56, and we're trying to find out how much this missing angle is. So we can do the math of 80 minus 56. And if we do our actual subtraction for that, we're going to line it up vertically. We're going to show good work. We cannot do 0 minus 6, so we need to borrow. 10 minus 6 is 4. 7 minus 5 is 2. So we know that our missing question mark is 24 degrees. Now we can check our work by doing 24 plus the 56, and we should equal our total amount of the two adjacent angles. Sometimes you're going to see them as pictures. Maybe it's in a pattern like this quilt type pattern. What do we know about this image? Well, we know this part here. We are missing this part here. But we really have a piece of information that is not directly shown, but we should know also. The angle, if we're looking at where the vertex of the two meet, would be right here. And if we look at that angle right there, what did it create? Hopefully you realized it created a straight angle. And how many degrees is a straight angle? It's 180 degrees exactly. So we do have a piece of information that was given, but we have to know that piece of information. So again, we can find our missing angle amount by doing 180 degrees minus 40 degrees. We should show our math, but to speed things along, we would get 140 degrees for our missing amount, and that would be our answer. The next concept is triangles. Triangles have first and last names when we want to start naming or grouping and categorizing triangles. The first name is their angle names. Triangles have an angle name of right, obtuse, or acute. If a triangle has a right angle in it, then it is going to be called a right angle. The other two angles in a right angle are going to be acute. So sometimes that confuses people because they want to say it's an acute right triangle. But if we think about a triangle, it is half of a quadrilateral. A quadrilateral equals 360 degrees. A triangle is going to equal 180 degrees if I add all the angles up together. Well, if I take 180 and I subtract out the right angle of 90, I'm left with 90 degrees. And I have to divide that 90 degrees among two more angles. So you can see that I cannot have more than one right angle in a triangle. I have to have two acutes and one right. So if it has a right angle, then that gives it its name. That is the same with obtuse. This angle right here is obtuse. It's going to have two acute angles, so it makes it obtuse. Now, how can you measure these if you don't have a protractor or can't use one, like, say, on a test? Remember, the edge of a piece of paper is 90 degrees. So you can stick a piece of paper right on here, and if the piece of paper shows a line outside of the piece of paper like it does right here, then you know it's bigger than 90 degrees, and that must make it obtuse. If both of the lines are inside the paper or on the edge of the paper, like right here and right here, then we know it's acute. So you can use the edge of a piece of paper to measure your angles if you do not have any other device. An acute angle is the only one that's going to have all three angles that say acute. If all three angles say acute, then it must be acute. So if we take a look at our example over here, we're going to start by giving it its first name. This angle right here is acute, and this angle is acute. This angle right here, we might have to take our piece of paper and measure it, but it is obtuse. It's slightly bigger than 90 degrees. So because this had anything other than acute, it is going to have the name of that angle. So in this case, its first name is obtuse. Now, all triangles have a first name, but they also have a last name, and the last name is based on the side names. An equilateral triangle has all sides equal. These little dash marks represent equal. They are called congruent. Congruent is a math term that means the same shape, same size. So all of these sides have a little dash mark, so they are all Let's get that R in there. They are all congruent. An equilateral has the word equal in it because all sides are equal. The next one is isosceles. I like to say this one as I saw some sleeves, because if you say I saw some sleeves quickly, it turns out to isosceles. I saw some sleeves. Isosceles. They sound very similar. Now, if I think of my sleeves, I have two arms that have sleeves, and my sleeves are hopefully the same length because hopefully my arms are about the same length. So on an isosceles shape, it's going to have two that are equal and then a third side that is not equal. And then the last one is scalene. Scalene means that no sides are equal. Now on a triangle, it should always show if it has any of these congruent sides, or it might have a measurement, maybe like 5 inches. It needs to have one or the other in order to give it its name. In this case, because it had those 2 dashes, 2 sides, I know that it is isosceles. Now, isosceles is one of those weird words that it doesn't quite spell out the way that it sounds. So this is a good one to write out and practice how to spell it so that you can get it right. So this example of a triangle is called an obtuse isosceles. Quadrilaterals. This is probably the biggest portion of the unit that needs some memorization. A good idea is to make some flashcards with the name on one side and then the definition on the other side so that you can start understanding what these are. Quadrilateral means a 4-sided shape. The prefix of quad means 4. Lateral means side, so it is a 4-sided shape. 4-sided shapes must have straight lines and they must be closed, meaning all the lines touch. So we have 3 different categories that a quadrilateral might fall into. It might fall into the trapezoid family, the kite family, or the parallelogram family. Let's start with the trapezoid family. A trapezoid has exactly 1 pair of parallel sides. Now on a shape, we put little arrows to show where parallel are. So the top and the bottom of this shape are parallel. If I extend these lines forever, they are not going to touch. The next one down is called an isosceles trapezoid. Notice it has the definition of a trapezoid, and it adds to the definition. So it has 1 pair of parallel sides. So in this case, it's still the top and bottom. And it has 2 congruent sides. We draw lines for congruency. Congruent, again, means the same. So an isosceles trapezoid is a trapezoid, but a trapezoid may not be an isosceles trapezoid. It has to have that definition. Both of these are quadrilaterals. A kite. Adjacent sides, remember, adjacent means they are touching by a vertex. Adjacent sides are congruent. So these 2 are congruent. These 2 bottom ones are congruent. Notice I'm adding a second line to show where the partnership pairs are. There's a pair there, there's a pair there, and these top ones are not congruent to the bottom ones, so this helps show the difference between where they are. My last family is the parallelogram family. This is the largest family that we have. So the parallelogram says 2 pairs of parallel sides, and I'm going to do some color changing throughout this. So 2 pairs of parallel sides. The top and the bottom are parallel. They will never cross or touch. And the side with the other side are parallel. Notice again, I drew a second arrow to show what matches. First arrows match together, second arrows match together. Now, if we look at every other shape underneath parallelogram, every single one of them has that definition within it. So all these shapes below a parallelogram are also called parallelograms. So a square is a parallelogram. A rhombus is a parallelogram, and a rectangle is a parallelogram. So we could draw these arrows in to match up where they all fall. Try and go quick, make that fast, but also make it look like arrows for you. All right, if we move down from that and go into the rhombus, a rhombus has, We'll change to purple here. A rhombus has the two pairs of parallel sides, but it also says all sides are congruent. So that means all the sides are the same length. If we look down at square, a square also has that definition. So all sides are congruent. So if I look at the definition of a rhombus, a square fits that definition. So a square can be called a rhombus. If I look at the definition of a rhombus, a parallelogram cannot fit it because of this added definition of all sides are congruent. So a rhombus can be called a parallelogram because it has that definition, but a parallelogram cannot be called a rhombus. Let's look over at the rectangle. A rectangle has two pairs of parallel sides, and it adds to the definition 90-degree angles. So all the angles are 90 degrees, and we denote those with little squares. If I look down at a square, it also has that definition. So it also has these 90-degree angles in on it. And so a square can be called a rectangle because notice it has both of the definitions in it. But a rectangle cannot be a square because a rectangle does not have all sides congruent. So the things on the bottom can be called all the things above it, but the things above it cannot be called the things below it. Knowing these definitions, memorizing these definitions is going to help you understand quadrilaterals. You might get some puzzle or riddles that ask you, what am I? So if I have 4 equal sides, I have 4 right angles. So it's a right-angled shape. It's got 4 congruent sides and 4 right angles. What shape did we create? We created a square. We're just going to abbreviate there. The next one. I'm another name for a quadrilateral. So we can look at that quadrilateral chart that has 2 sets of parallel sides. I can describe a square or a rectangle, but not a trapezoid. What am I? So this could be 2 shapes. This could be a parallelogram. Oh, sorry, this could only be a parallelogram, not a rhombus, because if it's a rectangle. The only thing that can be a square or a rectangle would be this parallelogram. So a parallelogram would be the shape. The next one, I am a quadrilateral 4-sided shape. I only have 1 set of parallel sides. So the shape that has only 1 set of parallel sides is a trapezoid. I have 4 equal sides and 4 vertices. I have no right angles. So this one is going to be our rhombus because it has all equal sides, but the angles are not 90 degrees. The next part of our video is not on your note sheet, so this is a good time to put it into your notebook as extra notes. This is math transformations. The first 2 transformations are transformations that you are probably pretty familiar with and have learned before 4th grade. The third one is new for 4th grade, and that is translation. Now, translation means the object is just going to slide to a new location, but it doesn't change how it looks. It's going to look the same, it's just going to slide over. A good way to remember is that in the middle of the word translation is an SL that can stand for the first part of slide. For reflection, we have the FL, And that's the first part of flips. A reflection flips the image over a given point. And then rotation has two T's in it because we are going to turn this shape. And it's going to rotate around a point. So this gives you some different examples, like thinking in a mirror for reflection. Think of turning of a doorknob for rotation. And think about when you slide an object such as a bookcase. Could be translation. Make sure you know all of these terms. The next one is also not on the note sheet, but important to understand: symmetry. What is symmetry? Symmetry is a line when a shape can be folded in a way that the two parts match. So if we look at this shape, all these different lines are where we could have folded and it would match up one side to the other. So a line of symmetry, we can draw a line of symmetry. This shape actually has another line of symmetry. We could draw it straight down the middle right here. So this one would have two lines of symmetry. Another type of symmetry, and this is the newer version that you probably haven't heard too much of, is called rotational symmetry. Rotational symmetry means that if I take this shape and I start to turn it, it will fit back inside the shape again. So if I turn this shape 90 degrees in a direction, it's going to fit right within itself again. So we call this one rotational symmetry, where it has 90 degrees of rotational symmetry. Sometimes you turn it all the way upside down before it has rotational symmetry, and that would make it 180 degrees, like these arrows here. If I only turn it 90 degrees, it would be tall up and down. But if I turn it another 90 degrees, it would fit within itself again. The top would become the bottom would become the top. All right, now's the time to put it to practice. Try these problems. Pause the video to give yourself some time to work. Resume to check your answers. If at any time you are feeling lost or don't understand, rewatch a part of the video. All right, we're back with the answers. Identify the type of lines created. These cross at 90 degrees, so they are perpendicular lines. The next one, if we know that the angle of X, Y, W is 60 degrees, because this bottom part down here told us that, then we can find our missing amount by doing 60 degrees minus 10 to equal 50 degrees for our missing angle. The protractor was already put on for us. The 0 is pointing at the bottom scale, so we're going to go up the bottom scale for the next one. We hit 80. We're not quite to 90. If we count the little tick marks, we got to 5, so we're at 85 degrees. We can also say this is an acute angle, so that measurement makes sense. The next one down there, number 4, Ellie draws a 4-line segment to make a figure, so it's going to be a quadrilateral. The figure has 2 pairs of parallel sides and no right angles. What figure did Ellie draw? Well, the definition that has 2 pairs of parallel sides is a parallelogram. And the last example that we have, name the triangles created by the diagonal of this quadrilateral. So we took a quadrilateral, we diagonally cut it in half, and now we can name the triangle that was created. All the angles on the triangle are acute, so its first name is acute. And 2 of our sides are congruent because this is a rhombus, so it is an acute isosceles. Feel free to get on iExcel to work on any of the skill plan for Grade 4, Unit 8. Get on Math Expressions, try any of the lesson checks in the Activity Center for Unit 8. Otherwise, rewatch the video if you're feeling like you need some more help. Make some flashcards for those quadrilateral definitions, and good luck.